All right. Let me just switch up an audio setting here. Okay, let's try that. So I haven't done this in a while. I did a couple live streams at the very beginning of the pandemic where I was getting drunk and playing with Grasshopper. And I just thought, hey, why the hell not? Let's do a little impromptu afternoon or evening Hypar live stream. Um, and I haven't advertised this at all, so there is nobody watching or in the chat yet. But I'm just going to tweet a link to this and see if anybody shows up. And if not, that's okay too. So let me grab the link and post it. And cool. So what I thought I would do is build a Hypar function utilizing the Hypar CLI, and we'll just kind of see how that works. This is not meant to be like super beginner instructional. I just kind of want to show how I work with the Hypar CLI and what the process of building a Hypar function looks like. Without further ado, let's dive in. So I already have the Hypar CLI installed. There have been a lot of improvements lately, and we've moved to .NET 6. We've updated it so that it can work on Mac Silicon machines. Lots of new stuff lately. But pretty much the principle of starting a new function is the same as it's ever been, which is you do Hypar new. You can also start from the wizard on the website, but I actually really like Hypar new, and you can see it's auto-completing -np, which is the same as --no publish, which is just a slightly faster way to get started. It'll just create your function without trying to publish an initial version of it. So the thing that I want to build today, and I'm just having fun here, is basically like a park or landscaping generator. I noticed that a lot of our sort of Hypar workflows don't have a lot of greenery, and I've experimented with building things like trees, functions, and other things. But I want to build basically like an automated park that maybe doubles as like a green roof or a roof terrace type of situation. So I think what I'm just going to call this is like landscaping. We can always change this later. And it's going to spin up that project for me. And you can see it's now using the .NET 6 SDK, which is super exciting. And once it's done, I am going to use cd to change directory into that project called landscaping. And I am going to open that up in VS Code, and we're going to dive in. The first thing I want to do is open up my Hypar JSON, which defines kind of like what the inputs and outputs of this function look like. And I'm just going to wipe away a bunch of these defaults. I actually don't want any inputs and I don't want any outputs. I'm going to work almost entirely with overrides. We probably haven't done a ton of like documentation of how to build code with overrides. So this will be a good introduction to, well, maybe not a good introduction, but it'll at least show you kind of like how to work with overrides. And so what I want to do is I'm going to start by just creating kind of like landscaping areas, which are going to be defined with profiles. So you like draw a profile and that becomes an area that should have some landscaping assigned to it. So what I'm going to do is create a section here called overrides, and I'm going to call it landscaping. And I am going to have to do a few things here. I'm going to have to define an element type, which is the context for this, basically like what kind of element are we creating. So we'll say context. And the form of this is a query, a JSON query to be specific. And we're going to do that by creating this query, which is going to say, give me all of the elements of type landscaping area, which we're going to do by star discriminator equals elements dot landscaping area. And you might be saying, well, what the heck is a landscaping area? Is that a type that exists? That type doesn't even exist yet. Eventually, I'll probably build a class for it and then ultimately like a schema so that it maybe can interact with other functions. But for now, I'm just going to create it here and we'll define a type for it later. I'm going to give it a schema, which is going to be the properties that are editable on this landscaping area. And so that schema, let's say I'm going to give it a boundary, which is going to be of type profile. So this is all just JSON schema that I'm editing here. And so the boundary property in the schema is going to have a ref of type profile. And it looks like it's not auto-completing the profile schema for me, but I happen to know that if I just type profile.json, let me just open that up and double click that that exists. Yes, there is a schema there that matches profile. That should be sufficient. I could probably use a couple other schemas that represent the same thing. And then the last thing I need to do when I'm defining an override is I need to specify an identity. And this is like a little bit of a complex concept. I won't go into it here in too much detail, but I'll talk about it a little more when we're writing the code. The identity is basically how we know that this landscaping area is this landscaping area specifically. So if the identity changes, Hypar treats it as a different element. If the identity stays the same, then it's assumed that you've kind of made a modification to the same element, maybe one that you already created. So this also takes the form of kind of like a schema. And what I often do, especially in contexts where I'm creating everything from scratch, is I'm going to use the add ID as the identity for this thing. I'll talk a little bit about what that means. We'll call it type string. And so far, all I've done is I've modified this Hypar JSON file, and I've defined the shape of the override that I want to create. I also want to do one other thing. I need to specify the behaviors of this override so that I can not only edit these elements when I create them, but also add new ones. And I definitely want to do that. I may not want to create any landscaping areas by default, but I want to allow the user to add a new landscaping area. So for that, we're going to add the behaviors property, and we're going to say add is one of the behaviors that we want. Add also takes a schema, and as a rule, I like my add schemas to match my edit schemas exactly. So the sort of base schema of the Hypar JSON or of this override is the edit schema, and then the add schema can just match that exactly. I thought about adding like a shortcut where you just say add true, just like we can do remove true, and it just automatically uses the edit schema, but just haven't gotten around to that. But this should be sufficient. We'll do Hypar init, which is the CLI command, which generates a bunch of code for us from this file. And you'll see that as I do this, it creates some classes over here. It's going to create an inputs class, which has objects which represent this overrides, additions. It has information about the landscaping. And these things basically follow the shape of the data that I've specified here in the schema. So a landscaping override has a value, which is of type landscaping value, which has a boundary property, which is of type profile. So that's going to be the profile that I'm going to be working with as I build this. So now it's time to write some C# code. There's this boilerplate that we stick in. I always wipe that away and just say var output equals new landscaping outputs. And this will compile. It won't do anything yet, but we'll fix that. I think the next thing I want to do is define a type, which is going to correspond to this landscaping area type. So I'm going to create a new file called landscapingarea.cs, and we'll say namespace elements public class landscaping area inherits from geometric element. So I can inherit from element, or I can inherit from geometric element. If I want to create geometry that's going to show up in the 3D view, I'm going to use geometric element. And I know that because of what's defined here in the schema, I know that this element type needs to have a boundary property. These schemas function as basically like subsets of the set of properties on the element. So if I want a property to be editable, I put it here in the override schema, but that property should generally exist on the element type. So we'll say public profile boundary, and we want that to be an actual profile. And for that, I'm going to need to import elements.geometry, and I'm going to make this a gettable and settable property. And it's saying, yes, it wants to be a non-null value when exiting the constructor. Yeah, fine. We don't actually have a constructor yet, but I'll just ignore that for now. So what I want to do is implement the ability to add this landscaping area. And so for that, I'm going to use some of the override helpers that let us create new elements. So we'll do input dot, there's an object on the inputs, landscaping inputs object called overrides. This is that code generated object we just saw. And if I do dot landscaping, which is this specific override, there are some helper functions that we added a while back, which make it easier to create overrides, especially complex ones that involve things like add and remove and other things like that. So typically what I'll do is I'll call the create elements method, and I'll say var landscaping areas equals landscaping.createElements. Now I have a few things that I need to supply to this method in order to tell it how to create new landscaping areas, how to update them if somebody edits them, how to know if this landscaping area is the same as another landscaping area. So let's go ahead and fill those in. So the create element signature, it's a little hard to read here, but it wants a pointer to the additions overrides, the removal overrides, a function to create the element, a function to identify or match the element to see if it's the same as another one, and a function to modify the element. And potentially also optionally, you can feed in a list of existing elements as well. So we'll do input.overrides.additions, and we'll do input.overrides. Oh, actually, it's additions.landscaping, specifically input.overrides.additions or removals.landscaping. And then we'll supply the three functions that we need, which are create element, match identity, and modify element. So usually I stub these out just like this. So I say, okay, create is going to take an add. We don't know what type that is yet, but we'll figure it out in a minute. And we'll say that's going to create a new landscaping area. And it's going to pass in the add. Then we're going to take an instance of the landscaping area itself and an identity, and then it's going to return a Boolean, which is whether or not these are the same. So I'll say, you know, landscaping area and identity, and we're going to return. And usually what I do is I actually put all of these methods in the class itself. So I'll say landscaping, I'll say actually this specific instance of the landscaping area dot match, and I'll pass it the identity. None of these things exist yet. I'm just sort of stubbing this out to sort of take the shape that I like to follow. And so we're going to drop in the last one, which is landscaping area and edit. And I'm going to call that landscaping area dot update. And so what the heck is all of this? This is basically the sort of minimum implementation for a complete add and edit override. And I'm going to have to add in a new constructor, which can take an add. The type of this add is the information which matches the add schema. So when I add this, I'm going to have access to a boundary, and I'm going to create a new landscaping area that has that boundary. When I look at the identity, the schema for this identity is going to match whatever's here in the identity part of the override. So I'm going to have an add ID piece of information that I'm going to be able to use to uniquely identify this landscaping area. And I have an update method, which is going to take an edit, and that edit is going to match the schema, which is the sort of primary edit schema for this override. So let's get to implementing those, and I'll talk a little bit more about each one as I do it. If I do command dot for a little helper, I can say generate constructor, and I'm just going to generate a constructor without storing the add as a property or anything. And so it's created a constructor for me. It's pulled in this addition object as the add. And so what I want to do is say, when I create a new landscaping area, this dot boundary equals add dot value dot boundary. And then for the purposes of identity, for the purposes of uniquely identifying this landscaping area in the future, I also need what I called in the schema here, the add ID. And the reason I like this, it works really well with add overrides, is that every add already has sort of a unique and persistent ID for the lifetime of the edit. Regular element IDs may change as you are, as you re-execute your function. And so the add ID is something that's stable. So I like to use that as the basis for a lot of identity strategies. And so in order to do that, I'm going to need a string that holds that add ID. So I'll say public string add ID. And I'm going to want to annotate it to match exactly the wording that I put here. There was a space in add ID, and so this also has to match. And we're going to do that. And I'm also going to say this dot add ID equals the ID of the add. And now we have completed the first part of this. This is going to create a new landscaping area that has a boundary property that is associated with whatever profile the user draws. And I'm going to also have to implement these other two methods, match and update. So let's go ahead and generate method match and generate method update. I'm just holding, I'm doing command dot. I think it's control dot on Windows as a kind of like quick helper in VS Code to spin up these methods for me. So what I want to do is, first of all, the responsibility of the match method is to say, is this landscaping area the same as some other landscaping area? When I'm editing it, if I make an edit to it, how do I know which landscaping area should that edit be applied to? And in this case, we've defined that the identity strategy is just to use the add ID. And so our match method should just be identity.addID equals this.addID. And we're going to return that. We have to return a Boolean to say this is a match. And so this is going to serve as the kind of unique stable identifier for this landscaping area. And finally, we want to enable the edit override to modify this element. So what we'll do is the edit, this is a landscaping override object, which has a value that has a boundary property. And this dot boundary is going to be equal to the edit's value boundary. And this also expects that we return a landscaping area. This is useful in case you have to create a whole new element based on a modification, but in this case, we can just return this. And this probably like isn't making any sense right now if you're not super familiar with Hypar elements, but this is a very common pattern when working with overrides, when building a function where you just want to like create elements of a particular type. And so this is almost a complete implementation. We can almost test this out on Hypar as is. The one thing that is missing is we've made this a geometric element. The property of a geometric element that allows it to show something in the 3D model is that it has what we call a representation. The representation captures like all of the geometry of that thing. And so what I like to do is override a built-in method on geometric element called update representations. So we'll say override update representations. And this method is called at the time that we generate the 3D model of the scene. And it allows you to be kind of like dynamic about how you generate the representation. And what we want to do is create, let's just start with kind of a flat area based on the boundary. So I'll say this dot representation equals, and I can create a new representation with a new list of solid operation like this is doing, but I think we can also use a shortcut and just say new lamina. A lamina is a type, if that term isn't familiar to you, it basically just means a surface with two sides. And we'll pass in the boundary. This should accept a profile as one of the arguments, and that should be that. And I may also want to update the material here. I don't, it's maybe not the right place to do this, but I'm going to go ahead and say this dot material equals, let's just make a new material grass. And there's probably a built-in material for this, but I'm going to give it a color of, and then let's say I'm going to use Copilot and ChatGPT to say, give me a nice sort of pale green color. Hex code for a pale green color is, yeah, sure. Okay, we'll see what that looks like. You can pass any string to any property that holds a Hypar color, and it will automatically convert the hex code in that string to that color. And so now we're ready to test this out. So let's do Hypar publish, which is going to go ahead and take this whole project, compile it, and upload it to the Hypar web application. And so in the meantime, I'm going to go in my browser and log into Hypar. And here I am. I'm going to create a new workflow, just a blank workflow that I'm going to use to utilize this function. So probably giving some sneak peeks of preview functionality. We've been working on a lot of UI improvements here, so you might see some things that look a little unfamiliar. I won't talk too much about those today. And you kind of have to reload the browser after the function itself is uploaded, because our function list doesn't automatically update. We will fix that eventually. It will just automatically update when you publish a new function. But for now, I just reload the browser and I'll do landscaping. Click add. And this is going to add that function. And this is where you'll see something. This is relatively new in the Hypar developer ecosystem. This is the concept of staging. So when you publish a function on Hypar, it is initially not published, not released. You only publish to a test version. And so I have to click test in order to go into the version of this function that I just published from the CLI. And now I have this button, which lets me add new landscaping elements. So we'll say add new landscaping, and I'm going to draw an area of landscaping. Because it's a profile, I can also like add holes or voids to it. I don't know. We'll try this and hit save. And this is going to go ahead and execute my function and create a new element that has that geometry. Now, why didn't that work? Did we create any elements? No. I know what I did. So I remembered to create these landscaping areas. What I forgot to do is actually add them to the output model. So we'll say output.model.add elements landscaping areas, and we will publish again. And so every time you publish, you are automatically updating the test version of your function. You are just continuously updating the test version. But that's not going to affect other users of your function. This is a way that you can kind of have access to like staging. So you can sort of test out new changes without worrying that you're going to break workflows for other people. So let's go ahead and wait for that to publish. And once it's done, I'll go back to the browser. And let's see. Okay, so that is done. I'm going to go ahead and maybe draw another profile again, just to cause it to recompute. I'll put a little hole in it, because why not? There we go. So now those two profiles that I drew show up. And so if I select one of these, you can see that it is an element of type landscaping area. It has a boundary property, which has a profile, which is the profile that I drew. When I go to edit it, I'm editing all of these simultaneously. Profiles are really nice in that they let you do simultaneous editing. And so I can make as many of these like landscaping areas as I like. And we'll hit save, and it will update those. And so we're up and running. We are now creating some elements. They're not very exciting, but we are actually creating new elements and we're managing them. And this kind of implementation here is often how I start almost any function. There's kind of like an element that I need to create instances of, and I'm going to use overrides to basically implement adding and editing those elements. And the editing, the way that that works, if I go in here and make another change, change the shape of this landscaping area, my code will know to apply that change to the same element because it has the same identity, the same add ID as the one that I originally drew in that location. So let's do something fun. Let's add something more to this landscaping area. So one of the things we could do is we could add maybe some areas of color. I think like a schematic sort of like park or something would probably want some little like blobs in it. And one of the things I often like to do is just go like get some inspiration on like Pinterest or something. So let's just go like search for, I don't know, landscaping plan. Go look at this, and some of these are going to be probably horrible. Let's say like, I don't know, public. How about, actually, since the thing that I really want is like roof terrace, let's say green roof landscaping plan. So okay, so there's some like pathy stuff that we might want to put in here, and there's some sort of areas of different color, different sort of patches with different kind of plantings in them. And so, yeah, there's sort of paved areas and planted areas and maybe some different colors to play with. I kind of like paths as a way to start here, actually. So let's play around with that. Let's allow you to, or actually, let's generate some paths. Why not? Let's automatically generate some path geometry randomly over our landscaping. And these probably won't be like the best paths, but this all looks pretty random to me. We can, I'm sure, a real green roof landscape designer would have all kinds of opinions about the strategy for doing this, but for me, this is mostly just like set dressing for an early stage project. So let's just let it create some random paths. So what I am going to do is, for each one of these landscaping areas, I want to create some random points, and I want to, maybe create some, I don't know, some pathways that connect through those random points. So let's see how that goes. I think we have the advantage of, and if I go to docs, we can check this out. I think I have the advantage of a Bezier class that we can use I have to go to Elements API, go search for Bezier. I'm trying to think of like, if we had nice smooth curves. Yeah, so we can draw nice smooth curves through using these points as our control points. That seems like as good a strategy as any to kind of start building this out. So what I want to do is say, and you'll notice that I like to code this way a lot, where I, instead of going into the class and defining this method, I like to pretend that the method already exists. I like to call it from the outside and then implement it. So we'll say landscaping areas. So we'll say var paths equals landscaping areas dot create paths. Or actually, since this is an array, this is a list of landscaping areas, we'll say select many la dot create paths. And this doesn't exist. I'm going to create a new file here called a landscaping path.cs, which is also going to be in namespace elements, and it's going to be public class landscaping path, which implements geometric element. We'll go from there. So let us now create this method, create paths. And this is going to create an IEnumerable of landscaping paths. And so what I want to do is create some random points. So let's stub this out with some pseudocode. So create some random points in the boundary, connect them with a Bezier I think in order to do any kind of offsetting, I'm going to probably need to tessellate that Bezier. I'm going to need to turn it into short segments. So tessellate the Bezier, offset it by path width. We probably are going to want to intersect that, trim that with the boundary. And then that's probably fine. So we'll flesh this out as we go along. I'm just going to make this return a list because I have a feeling that's what I'm going to be doing. And I'm going to say var list equals new list of landscaping path. And at the end, I am going to return that list. And so it's telling me this can be static, but it won't be able to be because I'm going to want to access the boundary property. So let's see. What I want to do is create some random points in the boundary. And so for that, I'm going to need a random instance. So I think what I'm going to do is create a static random on the landscaping area class. We could put this in all kinds of places, but let's just go ahead and do it here. So I'll say private static random equals new random. And I always like to give these a fixed seed, and I always use 11 because it's my lucky seed, and there's no other reason for it than that. So let us start by creating some random points. And so I want to create these random points within the bounding box of my boundary. And for now, let's just create a single path. We'll think about multiple paths later. But because the signature returns a list, we can always easily add that in. And so let's just say, var point count is, let's say 5. We'll say points as new list of vector. Yeah, that's fine. And so Copilot is suggesting some things for me. I don't totally love this. Do we have a random.next vector or next point? We do. Excellent. So random.next vector utilizes the elements extension methods on random, which makes it easy to kind of create new random elements. It's great for random materials or random colors, but I'll say var point equals random.next vector. And this takes a bounds, which is the bounding box that I want to create this in. So what we're going to do is I am going to create a bounding box for this boundary. So we'll say var bbox equals new bbox3. And I believe I can just pass it in this profile. So we'll say boundary is our profile. And I'm going to pass in that bbox as the bounds in order to create these random points. And so this is just going to create new random points that are within that box, which is not a guarantee that they sit on the profile geometry. They're just going to be somewhere in this bounding box. But that's probably fine. That's probably okay, because we can say if boundary dot, yeah, does that work? Boundary dot contains point. Sure. Looks like profile contains works. Then we're going to add our points. We're going to add that point. And from there, we're going to create a Bezier. So this has created some new random points in the boundary. Now we need to connect them with a Bezier. So we'll say var Bezier equals new Bezier. And this takes a list of points. So we're going to pass it the points. And we don't really care about the frame type. We might mess with that later. Okay, here's our Bezier. Now we want to tessellate it. Now, I don't remember if Bezier has any built-in methods for doing this. You can certainly sample it. I don't think there are any methods for turning it to a polyline or anything. So we're just going to do that ourselves by sampling it, probably overly aggressively. What we're going to do is say, let's say var segment count equals, let's say 30. And we'll say, yeah, it's even Copilot is hallucinating that we have this method, but it does not exist. So we'll say, we'll do a little loop for int I equals 0. I is less than segment count. And what we want to do is get a parameter, which is going to be I over the segment count. That's fine. And let's think about this for a second. The parameter space of this Bezier is going to be from 0 to 1. I think we always use normalized parameters in elements. We're about to find out, of course. And so if we're saying less than segment count, then we're never actually going to get to 1, because segment count, if I were equal to segment count over segment count, that would be 1. So we're going to be trimming off a little bit of our Bezier if we do this. And so what I'm going to do instead is let's just do less than or equal to segment count. Let's see how that goes. And we'll say we're going to need to collect a list of vertices. So our vertices equals new list of vector 3, and vertices, we're going to add Bezier.pointAt parameter. And pointAt says, yes, this, well, it doesn't say explicitly, but I think that's going to be a 0 to 1 parameter, and that's going to populate our list of vertices. And then we're going to say our polyline is new polyline of those vertices. And then we are going to offset that polyline. And I'm just going to pick an arbitrary distance for now. We'll say var offsets equals polyline dot offset on side. Actually, can we just use offset? I think this does like a thickened offset. This comes from the Clipper library. So yeah, I think that's fine. We'll say 1.0 is fine for now, and type dot square is fine. Let's see what we get. Now we want to intersect that with our boundary. But you know what? Before we even do that, I hate writing too much code without seeing what's happened. I guarantee I've made some mistakes here. So what I want to do is say, and this is just, yeah, it is an array of polygons, so we might have multiple offsets here. So I'll say for each var o in offsets, we're going to create a new landscaping path from that offset. Now, of course, we just saw that class. It doesn't have a constructor that takes a polygon, but it's about to. So we'll say generate a constructor. And yeah, let's go ahead and do it with properties this time. That's going to create a polygon called, oh, not a very good name for it. Refactor rename to our, I don't know. Well, let's just call it boundary again. Why not? And I'll call this one boundary 2. And just like before, we're going to need to give this some geometry. So I'm going to override update representations. And we're going to say, just like before, representation equals new lamina. And it's going to want that boundary as the argument. It doesn't know what a lamina is until I add a using for elements geometry solids. And we're going to say material equals built-in materials.concrete. And because I suspect if I've done everything the way that it's working in my head, these things are actually like overlapping, sitting right on top of each other. So what I'm going to do instead is just add, this is a cheat, but I'm going to just bump it up in space a little bit. I'm going to use a transform to move it up ever so slightly. So let's do that. Let's see how that goes. We'll do transform equals new transform 0.01. Sure, why not? Let's try that. We could also have made this an extrude and extruded it up that much. That might be more realistic, but I just want to see something. So I think all of that should compile. We can always check with a quick .NET build. Seems good. Let's go ahead and take advantage of Hypar run to try this. Now, I always get a little nervous. Hypar run can sometimes be a little bit flaky, but let's try it here and see how it goes. So when I want to do Hypar run, I go to my user menu, say test a local function. I'm going to copy this command, and I'm going to paste it, making sure that I'm in the root of my project. And it's saying this is the first Hypar run, so we have to create a new server project. It spins this up for us. It is building and starting and now connected to Hypar. So this is actually running the code locally, but doing it in such a way that I can interact with it here in the Hypar UI. So let's go ahead and just build like a simple rectangle here and hit save. And did we get anything? Did we get any exceptions? Did we get any outputs? Seems like we got something. We have a landscaping area, it thinks. It's not drawing it. So I'm gonna say let's abandon Hypar Run for now. So I'm gonna cancel this. I'm going to re-add my function called landscaping. I'm going to take it back into test mode, and I'm going to kill this with Control-C to shut down our little watch. And let's just verify. And I haven't published yet, so we won't see any paths if I do something here. But let's just draw a shape, any old shape. There we go. There's a thing. So I could just publish. Let's try that first. And we'll see if this worked. But if it doesn't, then I'm going to use my personal favorite way to debug Hypar functions, which is the test generate command. And I'll show you how that works. I see we've had a couple looky-loos. I'm looking at the YouTube metrics, but I'm probably scaring the shit out of people, so that's all right. Okay, so we have updated our function. I'm gonna go in here and just actually look, it's updating here for me. Did we get any paths? Let's check outputs. That's interesting. Okay, so landscaping area. Looks like it didn't create any paths. Let's just make sure that it reran here. Give it another little hole or something. I probably, oh, you know what? I made the exact same mistake as last time. I forgot to add the paths to the model. So what we're going to do is go back to landscaping and say output.model.addElements paths, and we'll do publish again. See what we got. This is probably going to look goofy as heck, but see what we can do. Okay, that's published. Give this another refresh, see what that does. So we got an exception. Must have at least 3 points. So I bet we didn't have enough points that weren't trimmed. But we can get in here and debug this. I'm going to copy the workflow ID from the URL. And I'm going to go down here and say Hypar test generate dash workflow or dash workflow dash ID equals, and paste this. And this is going to generate a test project for me. And in the generated folder, it's created a test that actually pulls in all of the inputs that I just supplied, like the profile I drew and other things. And if I run debug test, this comes along with the C# add-in for VS Code. It should show me where that exception is happening. So it looks like only 2 points satisfied. So probably what I need to do is say, one thing we can do, which will not satisfy it forever, is we can up the number of points that we try. And the other thing we can do is say, excuse me, if we, actually, let me think about this. I wonder if it's dangerous to use a while loop here. What I really want is for it to I want it to add 5 successful points. So let's do this. This might be, while loops are always dangerous. You always risk an infinite loop, but let's just say while points.count is less than 5, or less than point count rather. Then do all the same stuff. Copilot helpfully fills in the body. And so this is going to just keep trying to add points until it has successfully found 5 that fit within the boundary. And so that way we're guaranteed to have a minimum of 5. And let's just run that test again. Do debug test. And exited with code 0 is a good sign. That means it worked. The other thing we can do is we can go over to our generated folder, landscaping test results, and find this GLB file that it output. And we can actually drag and drop that into the Hypar window. And there's our path. Interestingly, it doesn't seem to have our, the actual like landscaping element, which is a little weird, but that's fine. It's not a very pretty path, but that's okay. We can iterate on this. So considering that worked, I'm going to go ahead and do Hypar publish. And now we'll play around with it in the UI. It's the most boring part. All right, so let's go ahead and like maybe make a slight change to our landscape just to cause it to re-execute. Eventually we'll make it so that it automatically re-executes as soon as you publish, but there we go. So ugly still, really not any great design shakes, but we're just getting started here, so that's okay. We've got a path, we've got some landscaping, you know, not going to win any awards, but if I add a new landscaping area over here, say some other shape, oops, like that, save, then it'll put a path in that one too. So it's going to put a random path in each one. And it looks like every time I execute this, we're going to get different paths because the machine that this function is running on has a tendency of hanging on to static variables like our random. So whenever I'm working with randomness inside a function, we have to do a little trick, which is we have to say, let's see, where our random lived in the landscaping area class. And I'm going to have to recreate this random. So what I'm going to say is, and really what I could do also is like create a global random that I manage. There are lots of different patterns for this, but I think what I'm going to do is just say public static reset. I don't know, or sometimes I call it initialize. Doesn't really matter. We'll say random equals new random 11. And then I'm going to have to call this at the beginning of our actual function. I'm going to say landscaping area dot reset. And then every time it runs, it will run deterministically. We won't get any new behavior in our random. And that's just a good practice. You want every function to always run exactly the same way, given the same inputs. And you just never know when the machines that are running these functions are going to reboot. So there's a risk of them sort of holding on to values this way. So let's take a look here. I think one of the things I might want is to allow you to edit the shape of these landscaping paths. So let's see how we do that. What I want to do is add another override. And I'm going to say paths. And it's going to have a context of discriminator equals elements dot landscaping path. And it's going to have an identity of, I'm also going to use an add ID here, even though we're not adding directly. And maybe I'll also use another property here just to demonstrate. We'll do like a path index or something. Let's just call it index of type integer. And then we'll do a schema And these are not going to be manually added. Maybe they will be manually addable in the future, but for now I'm going to say I want a centerline property, which is going to be of type polyline. Whoops. Polyline. Yes, thank you. And that should be fine. We'll say Hypar init. And so because, as I said before, the schema should represent a subset of the properties on the object, I'm going to have to go to my landscaping path class and make sure that it has a centerline property. So we'll say public polyline centerline. And set. And I'm also going to add that centerline polyline centerline to the constructor, and we'll set it. And we're also going to need properties that correspond to the identity. So we'll say public string add ID, get set, and we'll do JSON property add ID, and we'll do public int index. And I don't have to do JSON property on that one because the code name and the string and the thing is the same, but you could add this annotation to all of them. It's not a bad idea. So we are going to go to where we create this landscaping path, which is now going to be broken. I'm going to pass it in the polyline as the second argument, and I'm also going to give it an add ID that matches the add ID of this object. If I wanted, I could say, you know, dash path. And then if we're doing list.count, that does actually kind of work. But what I might do is just convert our offsets into a for loop so that I can use I as my index. So this says that the way that I know which path is which is that it is the nth path for this specific landscaping area. So this landscaping area has 5 paths. The 5th one is the one that I'm editing at any given moment. So let's continue. So we want to make this editable, and so we're going to need to do some more sort of override code work, but let's just see what it looks like at this point before I've done any useful work. So what I've done is I've defined an override for paths that applies to these elements and edits their centerline property. So when I do Hypar publish, what we should see is we're going to see a new row show up here that is going to allow us to edit the centerline of these paths. So let's go ahead and wait for this to finish loading. And I'm actually going to reload the browser so we get the latest version of that function. Again, that won't be necessary forever, but it is for now. So now we see we can also edit the paths which belong, the center lines which belong to these paths. So if I choose edit paths, I can edit. It's not the most beautiful edit experience, but if I wanted, I could get in here and start, you know, manipulating the shape of these paths. And we'll hit save. And it's not going to do anything yet because I haven't written any code that handles when that edit is supplied. So let's do that next. Let us go to our main function source here in the source folder. And so remember when I was talking about this method, create elements, I mentioned that you could pass in a set of existing elements. And so this is a case where we're going to have to do that, where we're going to want to pass in, this is basically the creating of the default paths. These are the automatically created paths. And then there's going to be another method which applies the override to those paths. And we can do that with input.overrides.paths.apply. And we're going to apply it to a set of existing elements, which are the paths. And so we're actually going to say paths equals, and actually, do we have to do paths equals? I think it does. Yeah, it does return the list. I don't know if that's actually necessary. And this also is going to take methods that are going to look a whole lot like what we did up here. So there's the collection that we want to modify. There's an identity match function, and there's a modify element function. We don't need the add constructor because we're not creating this from scratch. We're modifying existing elements. So we'll say path identity path.match, and we'll say path edit path.update. And we just have to implement those two things. So we'll generate our match, generate our update, go in and say, this path is the path you meant if the identity.addID equals add ID and identity.index equals index. Now, for some reason, it thinks that identity for, because this is the wrong identity type. So sometimes this can happen when you auto-generate your methods, is that your code editor hasn't yet figured out which type we're talking about here. So in fact, it's passed in the wrong kind of identity. So this is a paths identity, not a landscaping identity. So let's just change that, a paths identity. There we go, now it's happy. And similarly, when we do update, so this is because we're editing the center line, this tells me that our code where we did the offset earlier should really be in this class rather than in the landscaping area. So what we did is we specified a center line, and then from here we created a bunch of offsets and created a new path from that. So I'm going to change this a little bit. I'm actually going to modify my path so that it only takes a center line. And I am going to update it so that at the moment that we call into the boundary, we're actually going to generate that geometry. So I just, what we're going to do is go back here. So what we did is we took this polyline, we created some offsets, and we created a landscaping path for each offset. I think because now this is wanting to be one-to-one, I'm just going to like pick the best or single offset. So because this may eventually be in a loop, we might be creating multiple paths, but for now, I think I'm just going to say list.add new landscaping path from this polyline. And this I is just going to be 0 for now until we put all of this in a loop. And this is all going to get moved into our landscaping path class so that it automatically generates its geometry based on that center line. So let's go in. We will say that we're going to create our offsets, and we're going to use center line as the source of those offsets. And for this, I'm going to say we could do this in such a way that we actually create multiple laminas, one for each offset. Yeah, why not? Let's do that. Okay, so we'll say var var solid operations equals new list of solid operation, which is what a representation contains. And so for each offset, and actually we can just turn this back into a for each. So offsets, let's just do, how about this? Well, when we initialize our solid operation, we can pass it in a collection. So we'll do offsets.select O new lamina O. And our representation is going to be a new representation with that collection of solid operations. So this just says offset that center line. We're going to get back a list of polygons. For each one of those, that's what select is doing. This is a link statement to automatically create multiple elements from this loop, from this list. So this is going to return a collection of laminas, which we're going to create as our solid operation list, and then we're going to pass that into our representation. And so now all we have to do, because this is all happening in update representations, all we have to do is say centerline equals edit.value.centerline. And the same thing happened here. It's a landscaping override instead of a paths override. That should fix that. And now if we say Hypar publish, then we should be able to edit the paths and have their geometry update. So let's see if that works. Okay, so theoretically, if there's my edited overridden path, and if I make a change here, like drag this piece way over here and hit save, what are we going to get? It's going to apply that override. I'm not sure why we're getting multiples here. Interesting. Let's just revert all of our overrides to the paths so that everything is just as it would have been before I made any changes. So we've got one of each. And if I edit it and say this and hit save. Yeah, so we're getting doubles here. One way to inspect what's happening here is just to use Hypar test generate again. In fact, if I just use my up arrow to go back a few commands, I can do that again. You can inspect the values that are being passed to your function here in the generated folder. So I can see that I am getting some path overrides. I'm getting a single one, and somehow it's creating two paths. So I want to step through and see why that's happening. So it probably has something to do with the fact that I'm doing apply here. Let's just see. Update, I assume, is returning this. Yes, it is. So let's just see. If I put a breakpoint here and I go back to my test, and I say debug test, then paths right now is nothing. When we create our default paths, we get two of them. And then somehow, and let's just look, if these existing paths have an ID of FA9 and 37E, and then I bet this is link weirdness. The fact that it jumped back from here up here tells me that because of this is a trap you can fall into with link, because it basically tries to defer execution until the last possible moment. So I wonder whether that's part of the problem. So let's just see what we get when we complete this. So now paths is a collection of 3, and 2 of them have the same add ID, so that's another clue, potentially. So let me try my link hypothesis. If I do toList, I can force it to evaluate this link clause right away. I don't think that's going to be it. Let's find out. So now the paths, oh no, that was it. You see, before we had 3 paths by the time we hit this breakpoint, and now we have 2. So word of caution, watch out for link. Sometimes it works in ways that you don't expect. You can force it to evaluate at the line at which it's declared by using toList. So that should fix that bug. Go ahead and publish that again. And I want to do one more thing. I know we haven't really produced a very compelling piece of landscaping yet, but I think I'm going to do this as a series. I'm going to sort of work on this function over a series of live streams. You know, provided I get back to it. But you know, and I know this is probably not the best like instructional format if you're new to Hypar or Elements. I think this is more sort of like advancedness. Certainly I'm going fast. but hopefully, you know, I think actually a lot of our training resources have leaned on the side of, you know, sort of like very beginner intro stuff. And as we're starting to get a broader community of more advanced developers taking advantage of elements, I think it's nice to also have some content that runs at a little bit of a faster clip. So in theory, this should re-execute and only create an updated version of that path, yeah, and not the old one. So that's great. So if I get in here and I say edit paths, and I make some change, like move this over here, it will let me edit that thing, which is pretty cool. And I'm going to want to do all kinds of other stuff like make the width of the path editable. And let's do that. I think that's a reasonable last thing to do here. So in order to do that, we're going to go back to our override. In addition to the centerline property, I'm going to add a width property. And this is going to be of type number. And because it represents a length, I'm going to use Hypar unit type length. Whoops, length. My IDE has not been auto-completing the way it used to. I am going to set a minimum of 0.1, and these units are all in meters, and that's probably fine. And so we'll say Hypar init to get it to regenerate a code class. All of those override classes we've been working with are defined by these schemas. And so remember that schemas are always a subset of the properties of the element that you're pointing them to. So that means my landscaping path class needs to have a public double width. And that has to match exactly. And before, we used just 1 meter as the offset. And I actually think, if we go look, if we measure this, that's going to be 2 meters, because I think the offset actually offsets on both sides. So what I want to do is width over 2. And I'm also going to need to set a default width of, I don't know, let's say 1, actually. 1 meter seems fine. And we also need to make sure that our edit override here, width equals edit.value.width. And we'll publish this again. And this should allow us to edit the width of the paths in the UI. All right, so let's check it out. I'm going to reload. Whenever I make changes to the function definition, like anything editing Hypar.json, I always reload just to be safe. Now, if I, we got an error. Where did our paths go? Let me revert. I think maybe this is because, revert all. That's, oh, here we go. That's a bug. That's not supposed to be like that. Reload. So, okay, they did get a little thinner there, which looks good. And if I go in and I can still edit the boundary of this, so I can edit its shape and hit save, and it should change. And I can also edit its width. I can say, let's make this a big old fat path. There it is. So I can start to make individual changes to the geometry here. I think I'm probably going to call it there. I know this is not a particularly exciting result, but over time, what I'd like to do is kind of build up this function until it's really starting to look good. And hopefully I can pull it together to live stream those developments to kind of build this up into something actually useful over kind of a series. So since this was totally impromptu and I didn't advertise it at all, I don't think I got much in the way of viewership, and that's fine. Hopefully it'll be useful to folks as a recording. Please feel free to post questions in the YouTube comments, or just come find us on Discord. If you don't know about the Hypar Discord, you should. You can go from your Hypar account to Discord, and all of the Hypar dev team are always around to answer questions. And hopefully we can build this up as a little bit of a series and get a little bit more sort of like advanced Hypar function development captured here on YouTube. So for those who watched either live or in recording, thank you for watching, and we'll see you next time.